Welcome to part 5 of my Unitale crash course. This episode is a direct continuation of part 4, which is the introduction to wave creation, so watch that one first. This part will focus entirely on moving multiple bullets how it's done in the example waves, using tables and for loops. We will also learn how to spawn bullets during a wave and not just at the start, and how to remove bullets. Let's take a look at the wave we're going to create in this episode. Like last time, it's still pretty simple. More complex movement patterns will be covered in part 6. If you want to leave a suggestion for a movement pattern, be sure to join my own Discord, link in the description. Before we learn how to move multiple bullets efficiently, let's look at a simple and naive way to go about it. This is the script we wrote last episode. We could just copy the line that creates the bullet, give the bullet a new name, change its position, and copy all of the lines responsible for moving the bullet. And look at that! We've got ourselves a new second bullet. But what if we didn't want 2 bullets, but 200? Then we'd have to copy all of the lines we just copied but 198 more times. And what if we want to change the speed of all of the bullets after we're done copying? We'd have to change the numbers in all of the copied lines, which would be extremely time-consuming and an excellent motivation killer. So there must be a better way to handle many bullets, right? Of course there is. Otherwise, this tutorial wouldn't exist. Let's start with the very first thing we need to create, the bullet table. Remember tables from part 2 and 3? I hope so, because we'll be using them again. A quick refresher. A table is a variable which can store multiple values, like a few strings and numbers. In our case, the table will store all of our created bullet objects. That was info you hopefully already knew, but here's something new. All objects stored in tables are assigned to an index, which is a number. Consider this table with 3 strings. The first string is at index 1, the second at index 2, and so on. These indices are used to access the values of a table. This is our plan. We will add all of our bullet objects to the table and then access them later using their indices to move them. And the code for it will be super compact, and we won't need to change it if we add more bullet objects. Let's create a table called Bullets, like in the example waves. It will be empty at first, so write empty curly brackets. Let's add the bullet we created in part 4 to the table. To do that, call the function insert from the table object. This function needs 2 input arguments, things to write between the brackets. The first argument is the table we want to add a variable to, and the second argument is said variable. In our case, the table is called Bullets and the variable is called Bullet. Now the bullet is added to the table, but how do we use the table to move it? Inside of our update function, replace this line. We can keep the move function, but instead of calling the bullet directly, we will use our table. Write the table's name, then 2 square brackets and then 1 between them. Let's break down what we just wrote. First, we write the table's name that we want to access a value from. Then, we need to use square brackets to basically say, we want to access a value from an index of the table. In between the brackets, we write the index of the object we want to access. Because we currently only have 1 bullet added to the table, the bullet's index is 1 because indices start at 1 in Lua. Be careful. If you write an index without an assigned value to it, Unitale will give you an error stating that it attempted to index a nil value. A nil value is a value that just doesn't exist. Let's move on to the other big topic of this episode, for loops. A for loop repeats the code inside of it a certain number of times. If we combine the bullet table with loops, we can move and spawn all of our bullets without writing duplicate code, which is time-consuming to edit, as I've demonstrated earlier. We'll write 2 for loops in this episode, one for spawning a row of 5 bullets at the top of the arena, and one for moving all of the spawned bullets. Let's focus on the spawning loop first. Looking at some Lua documentation online gives us this syntax. I'll explain it thoroughly so you can understand it better. First comes a keyword, we've had them before like function and if. In this case, the start of a for loop is marked by the for keyword. Next comes the init value. Here we define a variable which will be changed by the for loop. In most cases it is called I. The min/max value is the value I must reach in order for the loop to end. The last value, increment, is the value that I will increase or decrease by every time the code inside of the loop restarts. Afterwards comes another keyword, do, then the code that will be looped, and, like functions and if statements, the for loop is ended by the end keyword. Let's look at an example for clarification. We set the init value to 1, the max value to 5, and the increment value to 1. If we simply print out the value of I every time the loop runs, we can see that it starts at 1, which is the init value, then increments by 1 every time, which is determined by the increment value. Finally, the loop ends with 5 because then the max value has been reached. Got that? Okay, first tables, now for loops, that's a lot to take in such a short time. Here, have some relaxing Undertale lo-fi music to ease your mind. Let's spawn our 5 bullets now. We could duplicate this line, but as I've told you before, duplicate code should be avoided whenever possible, so let's create our own function for spawning a bullet. This function will be called CreateBullet and will have 2 input arguments, x and y. Create a bullet object with the x and y values we specified above. Make it local so it only exists in this function because we won't need it anywhere else. On the next line, add the bullet to the table. Now we can call this function everywhere in our script and we won't need to create 5 lines for our bullet objects. So cool! Let's write our for loop now. We're going to start with an I value of 0 this time because we will use it for some calculations later. Set the max value to 4 because we want to spawn 5 bullets. But because we start at 0 and count up, if we set the max value to 5, the loop would actually run 6 times. Lastly, set the increment value to 1. Inside of the loop, we're going to create 2 more local variables called xPos and yPos. They will be the coordinates of the bullet that's about to be spawned. Lastly, the third line will include a function call. We're going to call our CreateBullet function here and pass the 2 variables above into the function. So, we create 2 number variables and then give them to our function. It uses them to create a bullet at the specified coordinates. Understood? Okay, let's focus on yPos first because it's the easier one. All of the spawned bullets will be at the same height, slightly above the arena, so we could just experiment with random numbers until we get good results. But there is a better way. Write arena.height to get the arena's current height in pixels. Something to note, height is always related to the y-axis, which is why it makes sense to use the arena's height here and not its width. Okay, divide the height by 2. Because the arena center is at y equals 0, we want to divide the arena's height by 2 so the bullets don't spawn far above the arena. We then add 50 to the result because we want the bullets to be slightly above the arena where they can't hit the player. The great thing about using arena.height is that if the arena's height changes, the bullets will still spawn above the arena because arena.height changes as well. So cool! Let's focus on xPos now. We will call the arena object again, but this time we will get the arena's width using, you guessed it, arena.width, which is related to the x-axis. We're going to add a minus before it so the bullets spawn to the left where the x-coordinate is negative. Like before with the height, we're going to divide it by 2 so the bullet lines up with the arena's left edge. Now we're going to add a value to that which will offset the bullets to the right. But we want the first bullet to be above the left edge and the last one above the right edge with the other bullets in between. So we need to somehow know which bullet we're currently spawning to offset it the correct amount. Well, it just so happens that we have a variable for that. A variable which keeps track of how many times the code inside of our for loop has been executed already. If we add I to our value, you'll see that the bullets are slightly offset from one another but not nearly enough. So multiply the I value by the arena's width and check it out. The bullets are now too far away from each other. Divide the arena's width by 4 because 4 out of our 5 bullets should have offsets and voila! There's our finished bullet row. This part was very math heavy, but I hope you understood some of it anyways. Always experiment around with the numbers and calculations to get a feel for the math involved. With the spawning loop done, let's focus on the loop which will move all of the spawned bullets. Create another for loop with I being set to 1 and the increment value to 1 as well. But what about the max value? We could set it to 5 because that's the amount of bullets we currently have. Instead, set it to number sign bullets. What is that, you ask? The number sign before the name of our bullet table returns the table's length. Because we have 5 bullets in our table, the max value will be 5. So what's the big deal? We could have just written 5, plain and simple. But, in case the length of the bullet table changes, the max value now changes as well, so all bullets move no matter how many are in the table. Let's call the bullet object from the index I and make it move. Because I changes every time the loop runs, this way we access all of our bullet objects from the indices 1 to 5, which is exactly what we want. But what's this? We get these weird lines across the arena. That's because a new row of bullets is spawned every frame, since the code for it gets executed every frame. We just didn't notice it before because they kept spawning on top of each other. Not so cool. So we need to somehow change the interval for the spawning of new bullet rows. But first, there's even more we need to learn about. I know it's a lot, but this is going to be the second last big new thing in this video, I promise. It's called the Modulo Operator. It's a mathematical operator like plus and minus. It has something to do with division. Remember, when you divide on paper, you get a result and often a remainder. Say, if you divide 90 by 60, you get a result of 1 and a remainder of 30. This remainder is exactly what the modulo operator calculates. So by writing 90% 60, you get 30. The percentage sign is used for the modulo operator. And here's where the Wavetimer variable from last episode comes in. Actually, quick intermission. It's better to call it something else like frame timer or even better frame, just so you don't confuse it with the Wavetimer variable from the encounter script. Okay, intermission over, back to business. In the example scripts, you often see spawn timer %60 equals 0. This is a check to see if the spawn timer divided by 60 yields a remainder of 0. This only happens when the spawn timer is a multiple of 60. And because it increments by 60 every second, the code inside of this if statement gets executed once per second. And this is exactly what we're going to use to spawn bullets during a wave. We're going to write an if statement really similar to this one, but with the number behind the modulo set to 120, so new bullets are only spawned every 2 seconds. Put our spawn code inside of it and voila! Bullets spawn during the wave and move as well, because they're automatically added to our table by our CreateBullet function. The for loop, which moves the bullets, runs as many times as there are bullets in the table, so all of them are moved. Way too cool! The last thing we're going to learn about in this already way too long episode is the removal of bullets. If you don't want a bullet anymore, you can just remove it from the attack and it disappears. To do that, simply call the remove function for the bullet you want to remove. But there are things you need to consider when doing that. The remove bullet might not exist inside of Unitale anymore, but it still exists inside of our table. And the problem is, once a bullet gets removed, it cannot be moved anymore or there will be an error. So once we start removing bullets, we need to remove them from our table as well, or the for loop will try to move them. The solution is to remove the bullet from the table after the remove function has been called. Armed with that knowledge, let's remove all bullets with a Y value below -170, because we don't need the bullets once they're off screen anymore. Now another error pops up and it's the dreaded attempted to index a nil value message. What is happening here? So, this is big brain time. We are removing the bullets from the table during the for loop. Once we remove values from a table, the holes between the indices that are left by the removed values are filled and the table becomes shorter in the process. But because the table's length is being used to set the max value, which isn't updated during the for loop, the last indices that are called don't refer to a bullet object anymore, hence the error. So what do? Well, instead of starting at the first index and counting up, We instead start at the last index and count down to 1. We do that by setting I to number sign bullets, the table's length, max to 1, and increment to -1, so I counts down instead of up. Now when bullets are removed during the wave, there won't be any invalid indices accessed anymore. And that's it. Wowie, this part took a long time to write and edit, but it's finally done. I hope this helps some of you, and I can't wait to hear your bullet pattern suggestions for part 6. Anyways, see you on my Discord, I hope. Creator out!